Okay, now that we're back and we successfully installed the driver, we got it all going good now. We're good to go to communicate, good to go to set up the entire process. So, not sure if you can see it or not, but on this right now, this chase, it has internal BEC power that powers the system. So, in order to safely program everything or what have you, make sure you unplug to your motor wires like so. That will ensure that this motor will not turn under any circumstance, and you're capable of then programming like the endpoints or what have you on the throttle with no worries. So also, I know if you're probably looking at this and you think the wiring is pretty shoddy, it was real pretty at one time, but in order to help with this video, I cut all the sheathing off of it and the cable ties, so that you to help to make sense of everything, so that I could share and show what it is that I'm actually doing with everything. So this will be much more clean whenever it comes time to start flying it. Alright, without any further interruptions or what have you, I'll go ahead and try to knock this on out and hopefully answer some questions. So now we're here, we got everything where we can communicate. Let's go ahead and close this. Now this is like it would be as if you just stepped up. We got our firmware updated, our drivers installed, we already know all that works good. So I went and disconnected the internet now, so I could pretty much have access to my GoPro to see that y'all are seeing what it is you need to see. So here we go. Power it back on. Radio's off. I'm gonna click on the brain symbol, hit OK, tell it we want the brain, not the micro brain. It's gonna open up the real cool MSH emblem right there. And also another thing, let's see if I can shrink this down. There we go. When you shrink the window, say if you're unsure or you need to do any dealings with your serial numbers or what have you, and somebody like from MSH or whoever it is, one of the distributors, probably be like www.overspeedrc.com, say they're needing your serial number. If you shrink down your window here, look at the top, not only will it give you your firmware that's running on your brain at this moment, like this one is now 1.3.051, the most up-to-date current firmware available, and it also gives the actual serial number of the unit itself. So when you're in full screen mode, you can't see any of that. There you go. And we'll go back to full screen. The only reason why I'm running full screen is just to help so that hopefully everything interprets well through the video. Also, just for those while I'm here, say you want to know what all the updates have been and when they came out, you can click on this help button and then hit the about on the drop down. Help, go to the about. Now this gives you all of the updates that occurred and when they occurred. See what all has changed over the past 2 or 3 years, 4 years, however long, ever since firmware 1.1.014, back when it first came out, or 1.2, I'm sorry, when it initially come out. But anyways, that's just if you want to know. Now we're live, we're communicating. We're going to start off. Everything with the brain is done as if you were reading from left to right. Up here is your options, and this here is the basic wizard. So start here. Tells you what to do. Download from our website. Install our certified drivers. On an electric helicopter, disconnect the motor. That's what we just did a second ago. Power up the unit. Connect the unit to the laptop using the USB micro. Start the unit configuration application. Select the COM port on which the unit has been detected. We've already done all that. That's what I went over just a few minutes ago. Now, the basic wizard will start automatically, and at the top are a series of images, which are these up here. Tells you what you need to do and how they recommend you follow each step systematically and complete each one before you go to the next step. 99% of this is going to be just as they say, and there are rare instances where you should skip a step, but those are very rare. It's good practice to just like you're reading a book and reading sentences, go from left to right. So this is the first step, giving you a rundown of what they're expecting and what needs to happen. Now we're going here to step. This is the actual first part of the setup process. If you're running a standard receiver, select standard receiver. Futaba S bus, pick that one. X bus, hot, M-Link, what have you, you pick that one. And DSM2, I don't know many folks that still run it, but if you do, select it. I personally run DSMX, and so does Bobby and most all the guys that I know of. So once you pick this, now you got it selected. It's going to be looking for your satellite, and your satellite for this one here, move the wires. As I said earlier, I just did this. I cut everything loose to make it easier to see, to trace out the wires. But anyways, it's dead, right? So what we're going to do is we're going to follow its directions. It says, select DSMX. So here's where it'll be when you first open one. Select DSMX. Select bind. Now, it tells you what to do. Turn off the transmitter. Cycle power to the unit. Turn on the transmitter with the bind switch pushed. So, transmitter's off. We're going to cycle power. First we're going to say OK. And cycle power to the unit. Now when I turn it back on, the satellite will be flashing. And move it forward some so you can see. I can't tell if it's picking it up. Yeah, it's picking it up. Okay, the satellite's flashing. You can see it through the video. That tells me that it's in bind mode. Now then, with my sticks down, everything in the normal flight position, I'm going to push my bind button on my transmitter and turn it on. Now, the light on the satellite just slowed down its blinking to let you know it's binding. Paused a second and went to stop, to solid. The swash plate jumped up and down, so that tells me that it's now bound. So my personal thing to do now is I just like to cycle power again. You don't necessarily have to. It's just a personal preference. So I'm gonna turn power off on the satellite or on the helicopter, and I'm turning power off to my transmitter. Now I'm turning the transmitter on first, as I would do to prepare for a typical setup or flight. Plugged in my helicopter. The satellite this time immediately energized or powered up, and the light went to solid, let me know that it does see my transmitter. Now we're going to proceed as normal. We're already bound. Now this tells you how to wire it. This is a very critical step in the process. Okay. This swatch is 120 ccpm, and it's going to be this one with the elevator servo in the front of the helicopter, not in the back, such as these. And this is like the old style Raptors where one servo does all your collective pitch, one servo does your aileron, and one servo does your elevator. That's for if you're real like updating a really old school helicopter. All right, these upper two are going to be 90% of your options. On this one, servo 1, servo 2. Servo 1's your elevator, servo 2's your aileron, servo 3 will be your pitch. On these are CCPM, collectively working together for everything. Collective pitch, cyclic, all that. All three servos move in relation to each other, and it is very, very important that you follow this setup precisely. I can't stress that enough. This one here see if I can set this in a way where you can see both. If you look on your brain, like it says right here, you got channel 456 on the top, the one on the top port closest to the governor output, then channel 3, then channel 2, and then channel 1. And also, besides saying the channels, it says 456/bind. That's where you would put your bind plug should you feel the need to bind it the conventional way. Channel 3 is your what is that? It's like S-bus type stuff. Channel 2 would be your typical auxiliary functions, like your auxiliary, say you want to put like a onboard glow igniter. That would probably be where you come out of that one for a nitro. Channel 1 would be your throttle. That's where your ESC plugs into. It also gives you directions here as to the difference between the ESC and the throttle servo for a nitro. Plug that into channel 1. Your signal wire has to be on top. Okay, it's very important, especially if you're using a V1 brain or V1 of any of the other brands. The negative is the bottom, the positive is always going to be the middle pin, but it's very important to get that signal on the very top. It could easily permanently damage your fly barless controller. So now we have go ahead and unplug this one. This is going to be my ESC. It's going directly to channel 1 throttle. Now servo 1 for this helicopter, just as it says right here, servo 1 is my elevator servo, the very front one. This has to be in servo 1 port on your brain, SRV-1. Servo 2 is going to be either your aileron or pitch, whichever you want to call it, on whenever the nose is facing away from me. It'll be, when I'm going to say I'm holding it in a tail end position, it's going to be the servo on going to the swash ball on the right hand side of the helicopter, which would be this one here. Let me see if I can see it. This one here. This is servo number 2. Alright, and this one here, lastly, will be servo number 3. And then servo 4, it says slash tail. That kind of answers that one. That was going straight to the tail. Now then, you plug in your satellite receiver to this side port here. Make sure there's no carbon fiber blocking your signal wires. Then I don't know, and I do not believe that it would matter, but I cannot swear to it right this second off the top of my head as to whether you must use satellite port 1 first if you're only using one satellite, or if it's okay to go satellite 2 port only, if that makes sense. I've just always chosen to plug in satellite 1. If I'm only running one satellite, I've just always chose to plug it into satellite 1 port. All my bigger stuff, anything bigger than a 450, I just automatically use 2 satellites, and I mount them in 90 degrees of each other. One on one side of the helicopter, one on the other, with the signal wire in the open air. So that's my personal method. But anyways, with a lot of the newer speed controllers, such as the Castle Edge series, the Hobby Wing, like what the Chase comes with, they're coming with an auxiliary out wire that can be designated as a throttle out, or I'm sorry, an RPM sensor out, letting the brain know what the pulses as the magnets are going by in the motor, so that it can monitor the motor's the speed that it's losing, or if it's overshooting, and correct accordingly. That's what this is right here. It's coming directly from the ESC. If you do not have an ESC like this, you will have to purchase a phase sensor, like I think it's Hobby Wing makes one, and Hyperion makes one, and I believe I'm not certain, but I believe MSH also had one on their website as well. Don't hold me to that one though right now. I can't swear to it. I will look into it though and post up and let you know. Anyways, you plug this one, the signal wire is all it takes. It doesn't have to have all 3 of these wires. That signal wire has to plug into the pin closest to the USB port. Like if you look, there's 3 pins. The one closest to the USB port is your signal. That's the only one that is of any importance. The other 2 doesn't really matter, unless you're running that Hobby Wing. And then it may, if you're running one of the RPM sensors or one of the phase type sensors, it may matter. But for the standard, the latest up and greatest of the ESCs, it doesn't matter. The ones with the auxiliary out wire. So you can plug it in or whatever. So that's what I'm going to do now. Now, you want to progress to this step. These first few steps are the most critical in this entire setup. This is where I calibrate my radio to the brain. And when you start this, you have to be certain that all of your reverse switches are in a normal position. You don't want to do any modifying as of yet. Now you go back. I just checked, everything looks good for me. Let me see if I can move this a little bit. There we go. Now, what I'm going to be doing now is I'm going to move it closer so I know you can see the numbers a little better. I'm going to go to my travel adjust screen for my JR11X. Everything is defaulted at high and low is 100, 100, 100, 100. Everything. Now, start with the aileron, and I'm going to go aileron right. It only goes to 76%. So right there I know I'm going to click on it, and I'm going to start raising this until I get to 100 right here. I don't care what my screen says on my 11X. What matters is right here. This has to go to positive 100 when you're going right, and this little slider, I don't know if you can see it through the video, but there's a slider in the middle right now, and it has to move right when I give a right command. So, and currently it does. You can also tell because this number is a positive, and if you go left, it's a negative. So right now I just raised it 3 points, and I went from positive 77 to positive 79. So I'm going to keep going until I reach 100. When I reach 100 with my finger holding it fully to the right on my stick, that's good. Now I'm going to go and do the same thing to the left. And it's going to be negative 100. Now we know that's good. If you look, your numbers should probably come out to about the same. They're both 130 and 130. Sometimes it'll vary. I noticed on the DX9 that I helped set up that it was off by 4 or 5 points. But as long as you hit 100, 100 and your max throws here, you're good. So we're going to call the aileron good and go to the elevator. Same thing. Nose down. It actually went to nose up. So I'm going to back out now, and I'm going to go to my reverse channel. I'm going to reverse the elevator. Go back to my travel adjust. Nose down. And it's now going to the nose down direction on the slider and negative 77. So we're going to scroll that one as well till we hit negative 100. And it's at also 130. Very cool. Now we're going to go nose up, and it went nose up just like it should. So now we're going to take that one to 130 as well. Or I'm sorry, not 130. It doesn't matter. I was wrong there. So this says 100, and it happens to be 130. So that's pretty cool. No, that one went to 131. I'm sorry. 131 got me 100. 130 got me 100 on the nose down. Negative 130. Ugh, I'm confusing myself. Now we'll go to the tail. So we're going to go nose right. If you have your servo hooked up, don't even pay attention to the direction it's going. Just pay attention to this right here. And except for making sure you don't accidentally bind it. It's probably a good idea to have your push rods completely disconnected here. Now rudder right gives me 75. So I'm sorry, nose right is telling it to go nose left at 75. So I'm going to go back to my reverse switch channel and reverse the tail. Now go back to my travel adjust, nose right, and now our slider went to the right. So I'm going to go all the way to 100 here, and it just went green 100%, and the slider's all the way to the right. Now I'm going to do the same for the left. That one ended at 132. So nose left, we're at negative 75. Okay, now we're 100%. Now our pitch. Our pitch, when we go positive, it actually moves positive, and negative moves negative. So for my radio, I don't need to reverse it, but I do need to raise my maximum position. And go to negative and do the same. Now then we both have them at green and 100. Now that one only ended at 127 for both. We'll go to this tail gain. That is for heading lock. If you look right now, it's green with the check box checked. The value is 78%. My radio right now has 100% for the heading lock position. And if I flip my switch, now I've got 78% and it's red without the box check. That's telling me I'm in